Indonesia has a huge potential in fishery and agriculture. For example, in 2018, Indonesia's agricultural land area reached 0.62 million square kilometers wide and kept increasing since 2004. Ironically, Indonesia got an early warning from FAO about the food crisis. Thus, the government tried to raise awareness about food sustainability. One of the solutions is to grow our own food stock. Moreover, since COVID-19 pandemic, many people spend their time staying at home with various activities including gardening. According to urban experts, the gardening trend will likely only happen for a moment, but growing our own food could make profit by selling our crops and seeds. This factor may be a reason for people to keep gardening. From these problems, we generate several objectives and key results, which are: first, designing applications that can help users get recommendations for plants; second, improving Indonesia's independent society in adequate food needs; and third, assisting users in caring for the right plants.
We try to reach those objectives using user-centered design framework, which is an iterative process that focuses on understanding the users and their context in all stages of design and development that contain all 4 steps, which are understand, specify, design, and evaluate. Understand. To understand the users, we conduct user interviews with 6 respondents in order to understand their experience and opinion in self-planting their food or other plants. Then, we use questionnaires to extract quantitative data related to things experienced by users related to the problem to be solved. Finally, we sum up the answers into empathy map to better identify and understand what the user is saying, thinking, doing, and feeling about self-planting at home. To summarize, we found that they have difficulty growing plants at home because they don't know what plants are suitable to grow and what are their nutritional needs.
Specify. After understanding how users feel about the situation, we start to specify it by discovering their main problem. We started with defining the characteristics of our end user. We achieved this with a user persona which is represented by Jasmine Kadir, a 23-year-old fashion designer. Then, we analyze each step of the user's journey on reaching their goals, point out their pain points, and finally formulate the problem statements. From the journey, we can take 2 main problems. There are: first, users have difficulty finding suitable plants planted around their environment, and users have difficulty monitoring and caring for the growth of their plants. So, we are determined to answer the question, how do we help users find and care for the plants that suit their environmental conditions? The question delivers us to the third stage, which is to craft the right solution that we are going to provide to our users. We first conducted a competitor analysis to similar solutions that already existed and analyzed them with SWOT analysis. After that, we brainstormed the idea for possible solutions in the form of features and grouped them with the Eisenhower matrix. Through this matrix, we determined the importance and urgency of each feature. Then, we developed an application that has the following features. Growpedia. Growpedia is the encyclopedia of crops to help users know the different types of plants according to their nutritional needs and how to plant the right plants according to their types. GrowLab is a laboratory that utilizes artificial intelligence to know which plants are suitable by knowing their surrounding environment. Forum is a place to communicate between users to share information or help users resolve issues they found while planting. My Plants is user plant collection information for helping them achieve and monitoring their plant growth. From the features and solutions that are stated above, we combine all of it to an application we proudly call Growee. Growee will help its users for their food growing journey needs.
The target users of Growee are people from any gender, with age ranging between 16 to 35-year-old that are interested in starting their own food growing journey. Growee is built to be in mobile application form. Mobile app was chosen because it's easy to use everywhere. It is also chosen because Growee needs GPS connectivity to detect the location of the user. The location is used to provide more precise information about what plants to grow. Here is our navigation, and here is our information architecture. Then, what do we do next? The next step is to evaluate and test our design. We created the first prototype of Growee and tested it on several users. We tested the prototype using usability testing on all its main features. The aim of the test is to make sure the apps are easy to learn, to check for errors, earn feedback from users, and quantify the success rate when a user is given a scenario. We gave the testers several scenarios and kept track of the steps they took to finish each scenario. We make the success rate with 3 categories: direct success, indirect success, and give up. Out of the 6 scenarios given to the user, 5 of them were done almost perfectly. Only one scenario resulted in a lot of give up on the result. The scenarios involving adding a schedule to my plans makes the tester confused on what steps to take. So we decided to go back to the drawing board and do some evaluating in our design. After gaining test results and feedback, we iterate our process and improve some of our design. The improvement includes: first, we rearrange the home screen. We remove the daily message card and change it with today's schedule or activities card. Then, we move the What's on Season list to the Grow Labs features, and we change the location to a personal greetings. Second, we add an encyclopedia page and make the recent search sound only when the search bar is clicked. The third, we hide periodic weather information at Grow Lab menu and rearrange the recommendation card using categories. Last but not least, we add the Add Tasks and Schedule icon to the menu so it can be easily reachable and recognizable by the user. So, here it is. Welcome to Growee. As the users enter the application, the user can log in or sign up. The user can also use their Twitter, Google, or Facebook account to enter the app. After logging in, the user will get through the onboarding screens, and here the user will take a look at the overview of Growee application. When the user finishes or skips the tutorial, the user will be taken into the home screen of Growee. One of Growee's features is Growpedia. In Growpedia, the user can search information on how to plan and grow certain plants. User can also search and filter to gain info on specific settings.
Next, we have Grow Lab, a laboratory that utilizes artificial intelligence to know which crops are suitable to be planted by knowing the surrounding environment. Then we have Forum, a place to communicate between users, to share information or help users resolve issues they found while planting.
In My Plants section, we could monitor our saved plants. We can see the details and recommendations about our plants, and also recommended gardening schedules through the Schedule section. We could either see the details of the schedules, edit it, or add new categorized activities.
Thus, Growee can provide a variety of benefits for users by finding suitable crops to be planted according to the surrounding environment, communicate within users to share information or help users resolve issues they found while planting, monitor the growth of plants owned regularly, and make the air fresher that could reduce the risk of respiratory tract disorders. Growee also makes an impact for the government because it also aligns with the second SDGs by the United Nations, which is zero hunger. By growing our own food stock, Indonesian society's food needs will be sufficient enough so that it doesn't depend again on the farmer.